All right, so this is questions 4, 5, 6 on chapter 5. Number 4 says, the internal energy of a system increased by 928 joules when it absorbed 492 joules of heat. Part A says, was work done by or on the system? And part B says, what is W? Well, one quick thing before we get started, as a little review. W, if it's positive, means that work is done on the system. But if we've got W negative, we got negative W, that means work is done by the system. Whoops. By the system. Okay. So if we work out question B, then we'll be able to work out question A, if that makes sense. Like it'll tell us it's positive or negative. So the formula that we're going to be using is delta E equals Q plus W. So here, delta E equals Q plus W. They already give us delta E, which is 928 joules. They also give us the heat, 492 joules. But we don't know the W. We could just work it out, though. We can just simplify for that. So we can do 928 minus 492. What would that be? Oh, nice. Okay, 436. Nice. So 436 equals 436. Thank you. But it equals W. Okay. So because 436 is positive, that means work is done on the system. So we got A, work is done on the system. And then B, well, 436 joules. That's the work done on the system. 436 joules. Number 5, I believe. Yes. It says a 60-watt light bulb is used to heat a gas cylinder for 2 minutes. The gas expands by 12.4 liters against an external pressure of 1.8 atmospheres. What is the change in the internal energy of the gas? So before we get started real quick, we see 1 watt equals 1 joule per second. But another thing, we also are going to need this little conversion. 1 liter times atmosphere is equal to 101.3 joules. We're going to need that later on. So we'll come back to that. First, our formula, what do we need? Change in energy is equal to Q plus W. Q is a little easier to find than W, so we'll start there. Basically, they tell us that 1 watt is equal to 1 joule per second. Well, how many seconds has it been going? We got 2 minutes. So in 2 minutes, we got 60 seconds in 1 minute. So 60 times 2 is 120 seconds. And then we see that 1 watt equals 1 joule. So if this guy has 60 watts times 120 seconds, we'll find the joules real quick. 60 times 120, and we get 7,200 joules. 7,200 joules. All right, so W, maybe, yeah, maybe let's use a different color for W, be more aesthetic. So W, little new formula is going to be negative pressure times the change in volume. Volume is always going to be in liters, so 12.4 liters is ready to go. And then the atmosphere, the pressure is also ready to go. So we can just plug in negative 1.8 atmospheres times the volume. It says it's increased or expanded by 12.4 liters, and we can just work this out. So 12.4 times negative, because the pressure has to be negative in this case, 1.8 atmospheres. 8. It's like a part of the formula for it to be negative. So negative 22.32. So the work equals negative 22.32 liters times atmospheres. Now, remember, W in this equation has to be in joules. So this is where this comes in. All you got to do is multiply this negative 22.32. Let's do it right now. Negative 22.32 times 101.3 so that we can end up with joules. So negative 22.32 times 101.3, 101.3 is going to give me negative 2,261. Okay, now work. This is going to be in joules. Negative 2,261.016 joules. All right. So now, real quick, real simple, I can find the delta E because all I got to do is subtract. So delta E equals 7,200 minus 2,261.016. Let me do that real quick. There we go. Okay, so we get 4,938.984 joules. There we go. Okay, next question. A gas in a cylinder was placed in a heater and gained 1.1 kilojoules of heat. Oh, okay, there we go. We get Q right away, that's good. Okay, so Q equals 1.1 kilojoules, or 1,100 joules. During the process, the cylinder increased in volume from 345 milliliters. Sorry, I just saw real quick. Milliliters. Remember, we're going to have to change those to meters. To 345 milliliters to 1,846 milliliters against an atmospheric pressure of 750 torr. Okay, so two things that we got to change. So they give us Q for W, work, which is the first thing they're asking us for. We need to change those milliliters to liters, and then those torr to atmospheres. So real quick, so 345 milliliters, that's pretty simple. Just like 1,846 milliliters. To change to liters, that's also very simple. So pretty much W equals, come on man, negative P times delta V. Now delta V we can work out to be 1.846 minus 0.345. Okay, so this is because 1,846 milliliters, that's just 1.846 liters. Okay, minus those 0.345 minus 0.345 liters is going to give us a difference of 1.501. So 1.501 liters. So we're going to have that multiplied by the pressure, negative pressure. But they give us torr. Not to worry though. 760 torr is equal to 1 atmosphere. Get out of here. Which means that all we have to do is put 750 over 760 to get our atmospheres. This gives us a simplification of 0.986842, but let's just say 0.987. 0.987. Remember, pressure has to be negative, so negative 0.987. Negative 0.987 times 1.501. 1.501 gives us negative 1.48. Okay, negative 1.48. 1487. Okay, L times ATM. This should look wrong to you, because remember, if we're calculating energy change, we are going to need joules. Remember, we do that by multiplying 101.3 times our whatever this is. So times 101.3, and we got 150.07. Let's just use that. Real simple. 150.07 joules. Okay. So now they want us to calculate on part B the change in internal energy of the gas in the cylinder. They give us the heat, 1,100 kilojoules of heat, or just joules of heat actually, minus our 150.07 joules of work. Okay, now we end up with delta E equals 1,100 joules minus 150.07 joules. Then delta E is equal to 949.93, excuse me. 949.93. There you go. Quick little overview. Hopefully, maybe you can take a screenshot, zoom in on everything. There we go.